The tuning fork has been a critical tool in the medical field for decades. It's an effective device for measuring neuropathy, or nerve damage, which can limit sensitivity to touch.
People are, in general, if their sensation's intact, very sensitive to vibrations that are created with this tuning fork we have. If patients can feel it for a significant amount of time, we think they have normal vibratory sensation.
That measurement of sensation in the feed is particularly important for people suffering with diabetes, which affects 8% of the U.S. population currently and is expected to more than triple in the next 2 decades. The traditional tuning fork can only give a subjective test result to a healthcare provider. Dr. Todd, a podiatrist based in Lincoln, Maine, had an idea to make this device electronic.
The idea for doing this project was to make it more quantitative in that we can make a reproducible vibration with an electronic device versus having the old analog, so to speak, tuning fork.
And when the vibrations go away, you can't feel it.
To realize his vision of creating an electronic tuning fork, Dr. O'Brien turned to the Advanced Manufacturing Center at UMaine. The AMC works with individuals and businesses that want to take an idea from the drawing board to reality.
It's a very typical project for the Advanced Manufacturing Center, where we are taking students and our professional staff and working for a client to develop a process and a project. The ultimate goal is to be able to help him commercialize this application so that he can build it and sell it within the state of Maine to help our economy grow.
Since they were first introduced to the medical field, the technology contained in a tuning fork has not changed. Making this device electronic meant starting from scratch.
He came to us with a drawing on a piece of paper, and he said, I have this idea for a device that will vibrate and will have a timer on it so that I can record how long something is vibrating and how long the person I am touching with this device can feel it. We took a standard tuning fork that they would use in a test, we learned how to use it the way he would, and then we measured the vibrations at the end of the tuning fork to figure out what was going on. We've taken this device, which has a whole lot of potential for human error, and we've turned it into this electrical device, which is the same for every operator. One of the most amazing things about this project is that actually it was a student who was in his senior year who designed all of the electrical end of this.
That student was Raymond, who helped create the electronic tuning fork for his senior project.
It was nice knowing that what I was working on actually meant something. It wasn't just a project being done for the sake of a project. It was actually a project that would be used and would help people. I love working here at the AMC. All the projects here are usually really interesting and difficult and fun to work on.
Through the AMC and Maine Technology Institute, which is really set up to help people like me do this, I was able to do it right here in Maine, which is important for me, and I wanted to do it that way.
With a working prototype now in hand, Dr. O'Brien will now begin clinical trials to test his invention. As development continues, the hope is that the electronic tuning fork will help medical providers diagnose potential problems much earlier, which could lead to less invasive treatments and big cost savings.
The whole thing with diabetics is trying to prevent amputations. About half of all non-traumatic amputations in the United States every year are from diabetics who become infected. The other thing that we're going to evaluate this for is people's balance ability. We know is decreased as we age, and it's one of the main reasons why people fall. Falls are a very big problem in the United States. I'm envisioning a potential retail kind of home version of this where patients could use the device at home to assess their own sensation